Okay, so we're going to continue on with the second part of this. I'm going to have to go down and down and down and down and down here. We're starting on page 6. Four, 5, okay, 6. Here we go. Covalent compounds. So this again is review for us. But I figured it doesn't hurt to keep reviewing. All right, so the first thing with covalent compounds, covalent bonds, remember that the atoms are going to share the electrons. They aren't like the ionics where they actually transfer the electron. This time they're going to share, and the one with a stronger charge, it'll probably go to that atom a little bit more than the other. And they are nonmetals. Okay, so it only has nonmetals present. So the example they give us right here is carbon plus O2. Okay, which gives us carbon dioxide. So now we're going to go through how we name these covalent compounds, and remember these are only nonmetals. Okay, so when we name the covalent compounds or these bonds, these compounds are going to have prefixes like mono, di, tri, tetra, penta for 5, hexa for 6, septa for 7. Octa for 8, okay? So remember, we don't use these prefixes with ionic compounds, okay? So let's go ahead and, so the example, carbon dioxide, the SF6 on the example here says sulfur hexa for the 6 fluoride. So Cody's going to tell us what NO2 is. No, you have to have nitrogen. Nitrogen dioxide. Okay, and remember, if we don't have anything, if there's not, if the first element of the compound is single, we don't put mono in front of it. We only, like, if it was N2, it would be dinitrogen. That would be correct. Nitrogen dioxide for this first one. Okay, so somebody want to tell me what the CCl4 is? How I would name that? Yeah, carbon tetra for 4 chloride. You've probably heard of carbon tet before, though, haven't you? Yeah. Use it as cleaning fluid. Carbon tet. Not a real nice compound to work with, but used to work with it in labs all the time. Now it's not around much. So carbon tetrachloride. Okay, so now the next one, N2O4, we get to do something with the nitrogen, don't we? We get to call it dinitrogen, and then because I have 4 oxygens, what do I call it? Tetraoxide. Dinitrogen tetraoxide. Really isn't very difficult, is it, when we get going? Everybody with us to this point? So all we're going to do is keep practicing these things for the next few days before we have the test, okay? So, beep, 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 beep. Okay, now the last, we're not going to do Lewis structures. We're not going to draw little dots. Okay, so we don't have to do that. So the last thing we're going to do today, which means we can finish early or you can work on all your homework here before you go, is to look at mole and mass relationships. And we already talked about that the mole is a unit of counting, and that we have 6.02 times 10 to the negative, 10 to the 23rd objects per mole. And we call that Avogadro's number. Okay, so what we want to do is figure out what portion or how much a mole of each compound weighs. So this last dot here says that 1 mole of anything has a mass in grams equal to its molecular or formula mass. So the example they used is, and we can just use the periodic table for this, is for carbon dioxide, which is CO2. We go to carbon on our periodic table and we look at its atomic weight. And that's 12.01. Okay, but they're just calling it 12.0. And so if I have a mole of that, that means I have 12 grams of carbon in that 1 mole of CO2. When I go and look at oxygen, it's 16 for its atomic weight. So 16 grams, and I have 2 oxygens, so I have to take 16 and multiply by 2 moles. So I got 32 grams. So all I have to do is add those together, and 1 mole of CO2 molecules weighs 44.01 grams. Is it? Yeah, they didn't put it on up above. I know, I looked at that and go, how the heck do you get an 01 when you only give me 00s? So it has to come from that. And depending on whether you use this periodic table or the one that I gave you, there's a few differences of 100th on some of these. I don't know why. They should all be the same as far as I'm concerned. But there's a few differences. But quite frankly, you know, if you do the math right and you're off by 100th, I am not going to mark you wrong, okay? So let's go ahead and try the moles. I'm going to go ahead and turn the lights on here. Let's try the next problems that we have on here. What they want us to do is find the molar masses. Let's try HCl first. Okay, so let's see if I can figure out how to use this pen on here and actually do something. Okay, so we got H. Whoops. Okay, I can't do anything, can I? Oh, there we go. Okay, there's H. So what does 1 mole of H equal? So we're going to say 1 gram. We're not going to go more than 100th, okay? I'll say 1. I'm going to be bad. Okay, what about chlorine? Oh, you can't see that anyway, so I'll do 1. Okay, so Cl, what is that? What's its atomic? 35.45? Yeah. We'll just do it to 100ths. Okay, so since I have 1 mole of H, which is 1, and 1 mole of chlorine, which is 35.45. All I have to do is add those up to find out what a mole of HCl is equal to. And so that's 36.45 grams per mole of HCl. That's pretty easy, isn't it? Why don't you go ahead and do PCl3? And then somebody can tell me how to do it. I'm gonna fool them. So what's the atomic weight for phosphorus? A mole of. Okay, so it's 30.97 grams per mole, right? Where's chlorine on my chart? Yeah, we just did that, didn't we? And how many do I have? 3? Has anybody multiplied 35.45 times 3 yet? I didn't hear you. 3.5. So that's grams per mole Cl3. So what I have to do is add those together, right? Is that right? Did I add right? Nobody checking my math? Yay, I can still add. Okay, so it comes out to 137.32 grams per mole of PCl3. Okay, let's do the last one, K2SO4, and that should solidify that we know what we're doing, I hope. That's actually the other class. We went a lot longer. We were asking a lot of questions, so we were doing that for homework. So if you want to do it on your own in here, you can go ahead and do that, or you can do it for homework. Yeah, on Monday we're going to go over it. Or we can stay in here and you can work on it on your own today. It all depends on what you want to do. Let's finish this last one. Yeah, I just want to finish this last one here. Yeah, we are going to do, yes, we're going to use that molar mass, and then the very last page is the one you're going to do for homework. I was going to ask, I was looking, what's sulfur? 32 point, I think that's the one where there's a difference. One chart says 32.06 and one says 32.07. Yeah. That's because it's the chart I gave you. The one in the book says 06. It doesn't matter. If you're a hundredth off, as long as I know you're looking at a chart and there's a difference, I'm not going to be. Basically, use whichever chart you have. So we've got how many S's? 1 S. We've got 4 oxygens. Oxygen is 16. So what 16 times 4 should be, what, 64? Okay, so all we got to do is add those all up, and we should come out with what? 8 and 2 is 10, 14, 10, 11, 17. Is it 170? Yeah, 171.27 for the whole. That's grams per mole of K2SO4. 171.27? Well, let's see, 8 and 2, yeah, I think you're wrong. 8 and 2 is 10, and 4 is 14, so it should be 174. See, that's what I get for not adding. Thank you for trying, though. Okay, 174.27. That's okay. What? Oh, okay. That's okay. Just be more careful when you're doing on the exam. All right. Okay, we're going on to the next page. This is the last calculations we're going to do for today. So now that we know how to figure out the molar mass, I'll turn the lights out for a little bit. The molar mass of what we're working with. Watch your eyes. Now we can figure out what percent of a mole of what the percent of a compound, what the percent one element is of a compound, or we can figure out what the percentage of a mole we have. If we give a weighted grams, we can figure out how much of a mole that is. So if we look at this first example that they have right here, they want us to say how many grams are in 5.6 grams per mole of sulfur. Sulfur has a molar mass of 32.07 grams per mole. Okay, so basically we can either use it as 32.07 grams per mole, or 1 mole per 32.07 grams, depending on whether we're going to multiply by moles or divide by, what the information we have. So, basically, they gave us 5.600 moles of sulfur. So the way they started out was putting 5.66 moles over 1. And I know that I have 32.07 grams of sulfur per mole. Okay. So basically, I can multiply those across as they have here. And I can cross out, I didn't push the pen. Cross out the moles. Okay, and it gives me 176, I can't read either, 179.6 grams of sulfur. Okay, so that's our example. So let's go through the next one. Okay, the molar mass for water is 18.0 grams per mole. Okay, so we want to know how many moles are there in 36 grams of water. So how would you do that? Could you set it up as a ratio? Kinda. I might do 1 mole. Whoops. I'll do it. I was going to try to do it. You can see this here now. So I got 1 mole of water per 18 grams. Could I set it up and just put 36 grams down here with X moles? That's one way to do it. How else could I do it? I could just take that I have 36 grams of water times, what would I have to put on the bottom? You put the mole on top, right? And put 18 grams on the bottom. Either way, I have to divide 36 by 18, right? Do both those ways make sense to you? I hear nothing. Yeah. You look a little bit confused. No. No, I'm good. Oh, okay, good. Your face looks. So basically, the answer is 2, right? Oh, 1. I can't write on this board. 1 mole of water per 18 grams. And then I put X moles. I should have put water up there. Is 36 grams. So you can either way, I'm going to end up cross-multiplying and dividing. I'm going to end up dividing 36 by 18 and coming up with 2 moles of water. Okay, so this is not too bad. All right, let's go to the next example. I'll try to push this up here so it comes up further into the screen. Okay, so now we have to figure out the molar mass for carbon dioxide. So how would I do that? I have a C, which is 12, right? Well, you guys are out of it today. Oh, I got to push the pen up here. So C equals 12 grams. What's a dioxide is an O2, right? What's 1 oxygen? So 16 times 2 equals 32. So if I add 12 and 32, we've done this example before. because they gave us an 01 on the other one, so I'll add it back in because they have no idea where it came from. So we have 44.01 grams per mole of CO2. Okay, so now it wants to know how many grams of CO2 or carbon dioxide. I think that is supposed to say, do we have in 4.12 moles of CO2? So how would I do that? That's pretty easy, isn't it? What do I need to do? Because there's 44.01 grams per 1 mole of CO2. And I'm going to have 4.12 moles. Nobody's going to do the math for me? No, you're not paying attention, huh? Okay. All right. So I have, it's 44.01 grams per mole of CO2. So times 4.12 moles, right? 181.32 grams. Everybody get that? Is it easier to watch me write on the board or write on the whiteboard? You can't? Okay. All right. We'll turn on the lights and do the rest of them on the board then. I was doing this for the kids online, but they can figure, well, I'll describe what I'm doing as well. So do you want me to do this last one on the board too? Okay, so we already know that we had carbon is 12 grams per mole, oxygen 16 grams times 2 equals 32. So we added those up and we got 44.01 grams per mole of CO2. Okay, so we got the first part done. Okay, now what they wanted you to do was figure out how many grams are there, and this is per 1 mole, right? So all they want you to do is figure out how much is in 4 moles. So we take 4.12 moles times 44.01 grams per mole of CO2. And the labels cancel out here. And when Eddie did his arithmetic, he came up with 181.32 grams. Right? Am I supposed to call you Eddie? What does everybody else call you? Maybe I shouldn't ask that. Or Fritz. Fritz. No, I'm not going to say that word on the videotape, okay? Okay. I guess Matt did a good one, and I'm not going to tell you what he did, but he did a really good one on the tape this morning. Okay, so we got 2 more problems to do before I'm going to let you do your homework. So let's look at this last one, or the second to the last one. How many moles of sodium sulfate are found in 108 grams of sodium sulfate? Okay, so what did you do? You've got sodium, so it's, give me the formula for sodium sulfate. Is it NaSO4? 2, okay. And they're going to ask, they want me to do, what, 108 grams?
Yes.
So what's the molecular weight of this? Okay, so Na.
Na2 is 45.9.
Is that already multiplied out?
Yeah.
So 1 is 20 something?
1 is 22.9.
Times 2, and that came out to 48. And sulfur? And O4 equals 16 times 4. So now I have to add all those up, right? Okay, so anybody got their fast calculation head on? Okay, so you have to add 48.98 for the sulfur, for the sodium. 142.05 grams per mole of Na2SO4. Okay, now they want you to figure out how many moles are there. It sounds like I'm digging for moles, right? How many moles? Did I write something wrong?
I think it's 45.
Oh. Does it still add up to the right total now? Yeah. I could have heard you wrong too.
I didn't say it. I just saw that.
Oh. I probably wrote it wrong because sometimes I mean to write it. So we got the right answer. So I've got 108 grams of this. So how many moles is that? How would I know if there's 142 grams in 1 mole? That means if I only have 108 grams, I don't quite have a mole, do I? So it's got to be a fraction of a mole. Uh-huh. So you can put the 108 grams of sodium sulfate, or you can do your multiplication. 108 grams of Na2SO4 times 1 mole is 142.05 grams, and that's of sodium sulfate. So my grams cancel out, and it'll tell me how many moles I have, right? Because these cancel out. Because I get 108 over 142. Anybody done the division? 0.76 moles of Na2SO4. That's how many moles there are in 108 grams. So it's a partial. That's right. So when you're looking at these, look and see whether your answer makes sense, too, if you're not sure which way to go. Cody, have you already done the last one? You want to write it on the board for us? I want some participation up here, so let's go ahead and explain what you're doing. Then that's fine. Do it. There's more than one way to do this. If you don't understand what I'm doing and you want to do it your own way, that's fine. I was trying to follow the book. So just tell us what you're doing. Want a pen? Okay, so you're going to figure out the molar mass of calcium nitrate, right?
Yep.
And we don't have any dyes or tris in that because calcium is a metal. So we got...
There's 40.08 grams of calcium.
So how much was that? 20?
28.02.
Okay.
Okay.
Okay, that's cool.
Then there's going to be 6 oxygen. There's 3 times 2 is 6, and that's 6 grams. You have to add all those together. You should get 164.1
Grams per mole, right?
That's how many grams there is in 1 mole of calcium nitrate.
I heard a 6 times 16?
6 times 16. 16 is the mass of oxygen times by 6.
So when you have it, yeah.
14.01 times 2 because there's 2 nitrogens.
So anytime you have the parentheses, you have to multiply anything inside by the number on the outside. On the bottom.
So for oxygen, it's 60. So it's times by 6.
Yes. because there weren't parentheses in the last one.
Wants to know how many moles are in 8.5 grams of calcium nitrate. So I just took 8.5 and you have to divide that by 164.1.
Which is the same thing as I did before, but I just showed them.
She did, but she did the whole thing out.
Yeah.
And that should give you 4.5 moles in 8.5 grams of calcium nitrate.
Not very many moles, right? Very tiny. Does everybody see how he got that? So see, this really isn't rocket science, is it? Basic algebra. All right? So that's the last thing we have to do on our demonstration for today. So let me go back to this. So the last page, you have all different kinds of questions here. This will be an example of what you might see on your test. I'll turn out the lights for you so you can see it a little bit better, even though you have your own copy in front of you. Okay, so you can stay in here and I can help you work on the first couple, or if you choose to want to go home and work on it yourself because you know what you're doing, you may do so. Okay, so you have, I want these done by Monday. I'm not going to give the answers till Monday. I want to see if you're going to be able to pass the test, okay? Actually, there's 2 pages, aren't there?
Yeah.
A front and a back. Front and a back. I didn't look at the back side, so yes, you need to do both pages.
Okay, so it's got the number in front of it. Does that time both of them by 3 or just front?
Okay, hang on a second. If you get a question, so does somebody else. He's asking me a question on one of the first questions.
It was just I couldn't remember what that was.
The 3, oh, when we put the, on B, when you put the number 3 in front of it, that goes 3 of the whole compound.
Okay.
So 3 N's and 3 O2s.
Okay, sounds good. And I can't remember the ionic is...
What's an ionic bond? Plus and minus?
That one, yeah, was that one's completely full? Like,
Yes.
These ones wants to know if it's ionic or covalent. And is ionic, I mean, they do match, and covalent's not?
Okay, an ionic bond has a metal in it. Covalent has no metals.
Sounds good.
Okay, so just remember that, and that's on your sheets, your little cheat sheets too, so remember to look at that on the test, okay? Because it's right in front of you.
Yeah, that's good.
Okay, let me turn this off so that I don't
Okay.
record you two. Okay, so if there's any questions,